Good morning, everyone. And we'll start with Commissioner Zenon.
Thank you very much, Paresh. Thank you all for joining us. This is such an important event that you host every year. Engineers are the backbone of everything we do here, not just at the BPU, but in human societies. It has always been the linchpin to progress. And what you do and what you continue to do is of the utmost importance for all of us. You know, if we look at the word engineering, it goes back to Latin and reflects a creative or novel idea, a new way of doing things. And that's really what engineers have done for history. Whether it's simple things that we take for granted, like the wheel, or more complex things that were used in military, the catapult, and so many other things. But think of the great engineering marvels that we just look to and appreciate. The pyramids, Hagia Sophia in Constantinople, all of the incredible architectural developments that are a result of engineering know-how. And through the years, we've actually developed so much more. Engineering has taken on so many different flavors, from mechanical engineering, chemical engineering, and aerospace. So if we look to the past, we see how many ways engineering has changed the world, and it will continue to do that. But today we have an added imperative. Engineers not only continue to change the world, but our responsibility here at the BPU is to restore the world. We need to continue the progress, but engineers are in charge of making sure that we can reverse some of the things we've done and restore us to a more sustainable and renewable world. So I can't thank you all enough. None of us in the state or in the country or in the world can be more indebted to any group of people more than the engineers. I can only say that I would like to encourage your continuation and to make sure that you fulfill the promise of what engineering is supposed to do. And if there's any way I can help, or the leadership at the BPU can help create an opportunity to encourage more coordination among our engineers, I think our mission will be fulfilled. And so I encourage you all to find a way to meet together, to coordinate your efforts, to communicate how the future could look. And if you do that, our world will continue to be a better place, and your jobs will be more fulfilling. The state and the world will be the beneficiaries, and I will be thrilled to help you in any way I can. So, Paresh, thank you for organizing this incredible Engineers Week. This is of critical importance, and if I can one more time just lend my voice to your efforts and to encourage you to continue improving the world around us. Thank you all so very much, and continued success.
Thank you, Commissioner. Upendraji, your next president will come anytime, so you can start your talk.
Okay. Thank you, Paresh, and I just want to thank all of you for joining on this special occasion of celebrating Engineers Week, and Paresh for organizing, and I have been participating in it since the beginning a few years ago. And first, I want to thank all the engineers at BPU, and BPU had a nice social media posting yesterday regarding the engineers, and so that was, I want to congratulate all of them. And my topic is to talk about the great engineers of New Jersey. And New Jersey is home to Thomas Edison. Thomas Edison, everybody knows Thomas Edison, whether it's a direct current, electric bulb, or phonograph, and motion picture, telegraph, voting machine, alkaline battery, and stock market ticket machine. So all these things were invented by Thomas Edison. And his counterpart for alternating current, Nikola Tesla, is also from New Jersey. And New Jersey is home to Bell Laboratories, which has produced so many patents in New Jersey. And when you look at William Boyle, George Smith, Michael Thomson, and Eugene Gordon, they were two of them received a Nobel Prize in Peace for coming up, inventing charge-coupled device, which is supposed to be computer memory. And then Boyle and Smith developed a digital imaging. And when we also have had RCA Labs, where George Heilmeyer has invented liquid crystal diode. And of course, when you talk about programming in information technology, C language and C programming was developed by Ken Thompson and Dennis Ritchie of Bell Labs. So most of the people, electrical engineers, are mentioning are from Bell Labs. And James Hillier developed the electronic microscope. And then the Stevens family, even though the locomotive was developed in England and in New Jersey and in the U.S., that was developed by John Stevens and Robert Stevens and Edwin Stevens. And first steam locomotive in New Jersey, also the steamship. And John Roebling is a well-known civil engineer who had developed the rope cable, which is used for the long span suspension bridges. And so he was instrumental in the Brooklyn Bridge being built in New York City. And then, of course, when you talk about Bell Labs and William Shockley, along with John Bardeen and Walter Bratton, they discovered a transistor. If you go to Homedale and at Crawford's Corner Road, you have a water tank that is shaped with three legs in the form of a transistor. And then, of course, Vladimir Zworykin was known as the father of television. And of course, he gives credit to all the team members. And of course, Morse code, Samuel Morse is also from New Jersey. And William Carrier, who's also, he discovered the air conditioner. So if you know, when you see Carrier Engineering, I think it was started by William Carrier. So there are several engineers, and these are some of the most and highly notable engineers. And New Jersey has been home to all of these engineers. There are several more. I think within 5 minutes, this is what I could cover. And so we should be very proud in the state of New Jersey that there are so many engineers, not only civil, mechanical, electrical. And so we have great institutions like Montclair State, Stevens, and Rutgers University, New Jersey Institute of Technology, Rowan University. They're all there for teaching engineering education and computer science. And I think New Jersey is a great place. And BPU is located, of course, New Jersey Board of Public Utilities, and organizing this event. Parish Trivedi, hats off to you and congratulations.
Thank you, Commissioner. Mike, you are next for your presentation. Your screen share and start, please.
Okay, here we go. Can you see my presentation?
Yes.
Okay, well, welcome everybody. What I'm going to talk about is advancing microgrids in New Jersey. The topics I'll cover are: why are microgrids important? How do microgrids work? What has BP done and BPU done, and what will BPU do? And what are the challenges and opportunities with microgrids? This shot may be familiar to some of you that were around here in 2012, where Superstorm Sandy came to visit.
Yes.
Mike, you're muted.
I think it muted all of us.
Some of these images may be familiar to you from Superstorm Sandy. We saw widespread destruction of the distribution system, among other things. When we have wires mounted on wooden poles and are dependent on that, that makes us vulnerable. And a lot of our backup diesel generators didn't work. Oftentimes they're not run very much, and when you try to start them up after months of inactivity, they don't really work very well. And with the roads being impassable, those that did work couldn't get fuel. So it wasn't a good situation at all. And power was out for up to 2 weeks through much of New Jersey. So to start off with microgrids, let's start by looking at some of the familiar components, distributed energy resources. Some of these things are familiar to us, such as solar PV cells, wind turbines, existing diesel and natural gas generators, combined heat and power systems that are often used at hospitals, in the increasingly important energy storage and EV chargers, among other things. So what is a microgrid? Well, it's a group of interconnected loads. And when I say load, it's say a facility that demands electricity, like a police department or a town hall, and our distributed energy resources that can operate as a single controllable entity with respect to the grid. The components of a microgrid are interconnected loads, that is the buildings themselves, the distributed energy resources, control and communication systems, often a single point of common coupling to the grid, and switchgear that allows the microgrid to connect and disconnect from the grid. So how do microgrids work? Well, under what's called blue sky or normal operating conditions, the microgrids can be connected to the distribution system, and they operate in a synchronized manner with the distribution system. However, when under a so-called dark sky condition, when the distribution system is taken out by often natural causes like a storm or a hurricane, then the microgrid can disconnect from the main grid and operate in a so-called island state and operate independent from the grid until such a time that the main distribution system is turned back on. Across the state, there's a number of so-called level 1 or simple microgrids and level 2 or campus scale microgrids. BPU has supported the development of these types of projects over decades. So a single simple microgrid consists of a single building, and a campus scale microgrid consists of a campus such as a university. Rutgers Bush campus is shown here in the picture. They have a combined heat and power system that provides energy to the Bush campus. Another very noteworthy microgrid campus scale is the Princeton University microgrid, which also has a combined heat and power system. And that Princeton microgrid was held up as an example of energy resilience during Superstorm Sandy, when the power all around the university went down, but the university remained operating and had power. And to make it interesting, this vaunted CHP system at the university is slated for decommissioning in the future years, as Princeton is going greener and is choosing not to rely on their natural gas fueled CHP system over the long term. There's also thermal microgrids, and there's two good examples in New Jersey. There's the Atlantic City thermal microgrid, which feeds several of the casinos in the Atlantic Care Medical Center. And some of you may know in Trenton, there's also a thermal microgrid. It's It's still over near the DCA, Community Affairs. It's shown in this picture right here. And it distributes steam, hot water, and chilled water to about 12 million square foot of buildings throughout the downtown area. And the system extends from the prison all the way to the DEP building, which is right across the street from BPU here. So you may note that the DEP building doesn't have their own air conditioning system. They don't have their own heating system. They rely on this district energy system from this central plant. And fun fact, John Stewart's father used to be the operator of this downtown CHP system. And that brings us to the present day, where the BPU is looking at so-called town center distributed energy resources, or TCDER microgrids. Town center microgrids are also known as community microgrids, level 3 microgrids, or advanced microgrids. They're generally developed in downtown areas. In New Jersey is configured in such a way that a lot of critical facilities, municipal facilities, exist in clusters, such as police, fire, EMS, town hall, are more or less in the same areas. So these are the town centers that we're focusing on. And importantly, these town center microgrids cross multiple rights of way. More on that later. And there's very few level 3 microgrids in the USA. There's one that's started up in Illinois and a couple in California, but that's really about it. Here's an illustration of a town center microgrid. And you can see the loads, such as the town hall, police station, fire station, senior housing, and a hospital. That's kind of typical for the projects we're working on. The microgrids are served by DERs, such as solar and energy storage. Many of them have existing generators, which is either diesel or natural gas. They're not part of the TCDER program, but they exist. And these systems are connected to the grid and may disconnect from the grid during times of emergency. And you'll note the roadways here, where one of the key characteristics of a town center microgrid is that they may cross multiple rights of way with a power line. And that raises the question of where's the dividing line between an electric utility and a town center microgrid. So by statute, the dividing line is a power line may cross one right of way. If you go to two right of ways, then you're a regulated utility, and that's a big deal. So microgrid operators and microgrid designers want to avoid that circumstance. Our town center microgrid program focuses on critical facilities. And so what do I mean by that? Under the FEMA designations, there's, for example, category 4 critical facilities such as hospitals, police, fire, wastewater plants, etc. Category 3 are areas or buildings that house lots of people, schools and public housing complexes. Category 2 and Category 1 are low hazard facilities. And that's me on the left in this here picture of this fire department. What's interesting above and beyond the FEMA categorizations, what might a municipality consider to be a critical facility? Like, for example, if you know that a hurricane's coming, what are you going to do? Well, you might go to a grocery store. You might go to the pharmacy and stock up on medicines. You might go to Costco. You might go to Home Depot. So while such facilities are not necessarily like high on the FEMA ranking, they're often considered critical by a municipality and by us as well. So that creates interest in what buildings are actually critical. So what's BPU up to? Well, in terms of energy resilience, there's a number of ways to skin that cat. We can harden the overall distribution system. For example, during Sandy, I think 20 or so substations were flooded. So raising the substations up on platforms like this is effective. So that is being done across the state. And in the 2015 Energy Master Plan recognized town center microgrids as being a key tool in the world of energy resilience. New Jersey also created the Energy Resilience Bank, NJERB, and we used $200 million in federal Sandy money to implement energy resilience projects, all CHP, combined heat and power systems at hospitals and wastewater plants. EDA is the program administrator, and BPU provides the tech support. I've been the tech lead for the ERB since its inception. And all the projects are under design, construction, or operation. And here's a list of the projects that the ERB has developed. And just one example is the first one out of the box is the CHP system at St. Peter's Hospital in New Brunswick. So here's a brief summary of the history of our microgrid program. Presently, we're in the engineering design phase. Here's a location. Here's a map showing the locations of the microgrid projects around the state, and we selected these in part based on siting facilities in each of the electric distribution system service territories. Orange and Rockland isn't in it, and those that were impacted by Superstorm Sandy. Here's the lineup of our current projects. We have 7 projects right now undergoing engineering design. We have partially funded these designs to the collective tune of $4 million. And just some illustrations of what some of these projects look like. Hoboken was severely impacted by Superstorm Sandy. For any of you who were the downtown a couple of years ago, you saw that the street was torn up. They buried conduit right down the main drag of the downtown to serve as kind of the backbone of their microgrid. And some of the critical facilities that are connected to it include pumping stations, both for wastewater and for flood control. Some areas of Hoboken are below the level of the Hudson River, so it's quite vulnerable to flooding, and the pumping stations that are will be supported by the microgrid are a key part of it. Hudson County is pretty interesting in that as of late, there is a proposal from the adjacent United Parcel Service facility to create an EV charging hub for thousands of their medium duty and heavy duty trucks. They want to go green and convert their fleet to electric trucks. And one of the key questions is, well, how do we power this? How do we power all these trucks? They're looking at 40 megawatts of load, which is ginormous. And they're developing that now and considering things like a renewable natural gas fired generator to help charge the trucks. This one is Highland Park. Highland Park has a dense downtown where they plan on connecting their schools, their town hall, police and fire, etc., to the microgrid, and to connect to an existing PSE&G Solar for All solar and storage system. The BPU commissioned NJIT and Rutgers to study how to finance microgrids. I mean, we at the BPU have financed the design, but we have not financed the construction. So we engaged these universities to help us figure that out. And one of the findings from this study was that there's key barriers to microgrid development in New Jersey that must be addressed prior to construction. More on that in a minute. So what are some of the challenges and opportunities? And this word salad on the right kind of signals some of these challenges and opportunities. So firstly is utility franchise rights. I've mentioned that microgrids cannot cross more than one right of way with an privately owned electric wire. If you go beyond that, you're a public utility. So utilities tend to view these town center microgrids as an encroachment on their franchise and tend to push back, sometimes quite vigorously, on the development of these microgrids. That's a significant headwind. Also, there is no body of statutes, regulations, tariffs, or policies that are developed to facilitate town center level microgrids. The manner in which they support overburdened communities is a challenge. For example, in our award criteria, we had specified that these facilities must serve as a public shelter during times of public emergency. So all of them have that capacity. And what's the, say, division of labor between utilities and private parties? Who owns the distribution system within the microgrid? Who owns the DERs within the microgrids? And who will control when the microgrid connects and disconnects from the system? One of the challenges is a heavy reliance on natural gas. I mean, during Superstorm Sandy, we had found that the gas distribution system is about 10 times more reliable than the electric distribution system by virtue of the gas system being buried and the electric system being mounted on wooden poles with wires that are vulnerable to damage. For a critical facility to maintain continuous power, some of the existing designs do indeed rely on natural gas to a great extent. So, but also consider that there's two real means to address climate change. One is to reduce our emissions, and the other is to become more resilient. So, the original intent of these microgrids was the latter, to become more resilient. What is the impact of microgrids on the utility grid? Do they serve as a net benefit, a net detriment? How do they interact with the grid during blue sky conditions and dark sky conditions? How to finance these things it continues to be a challenge. And who benefits and who pays? For example, the customers within the microgrid benefit, but also the entire municipality benefits, and to somewhat lesser extent, the regions benefit from services provided by hospitals, and the whole state benefits by exploring this town center microgrid pilot. And lastly, what is the absolute value of resilience? That's still a bit of an unknown. For example, if you're home and the power goes out, how much are you willing to pay to turn the lights back on after sitting in a cold, dark house for 5 minutes? What about a day? What about a week? How much are you willing to pay to turn the power back on? So everybody has a different, different number for that value. So pricing this value into the overall benefit cost analysis remains a work in progress for us and throughout the country. What are the opportunities? Well, over time, we've seen the cost of, for example, solar and storage drop dramatically. So that's helpful for the development of microgrids. The controllers and the software get better over time. When the power goes out, the public lets us know they are not happy. So having resilient features is certainly a critical thing. And there's always been bills in the legislature, for example, which call for various configurations of microgrids. And finally, we at the BPU are being supported by the Department of Energy in several respects, and that's shown here. We back in 2021, it was the NARUC put out a solicitation which said, hey, who would like some help from the DOE and the national labs on your greatest challenges? So we submitted an application, say, yes, help us with microgrids. So the DOE and these labs have teamed up to help us. And here's kind of a list, my shopping list of the things that we wanted them to help us on, and they are indeed helping us with these topics. And finally, in January, we've applied to the DOE for a substantial amount of funding, $130 million with a 50% cost match between us and our partners to help construct these microgrids and help interconnect them to the grid. So the paper went in January, and this month we're expecting a notification from the DOE either encouraging us or discouraging us to submit a full application. So we're excited about that and checking our emails all the time. And that concludes my microgrid presentation. So thank you. Open the floor for questions. You're on mute, sir. Sure.
I have two questions. One, are you going to do anything for the individual home, residential market, and in New Jersey, are they allow you to do the net metering?
Or will there be microgrids for individual homes? Not in this particular configuration. No. Well, we're more focused on critical facilities. And the net metering, I mean, that remains in action in front of the board. So we in the microgrid program are tracking that as well, and we'll adapt to whatever the outcome of that board proceeding takes.
Thanks.
You're welcome. Anything else? Hearing none, Paresh, I'll turn it back to you, sir. Thank you.
Okay, thank you very much, Rupa. Now you can take over.
Thank you, Paresh. I'll just bring my presentation. Can everybody see my
Yes.
screen? Okay. Good afternoon, everyone. I'm Rupa Desmukh, Senior Program Manager in the Division of Clean Energy at the BPU. I started my career as an electrical engineer, so I'm really happy to be a part of this Engineers Week event. Today, I'm going to talk about our work on buildings decarbonization. Just let me move my slide. Yes. So why are we worried about buildings? As this chart shows, buildings are responsible for 25% of total GHG emissions in the state, next to transportation. And if we look at emission sources in residential buildings, natural gas is responsible for 87% of emissions, and 71% of the natural gas that's consumed is used for space heating, while 22% is used in water heating. Similarly, in commercial buildings, 82% of the emissions are due to natural gas, and 64% of that is burned for heating commercial spaces, followed by 18% for water heating, and we also have some 13% for cooking. So where, you would have restaurants, hotels, dining halls, such type of buildings that would be consuming natural gas. So this clearly calls for action, right? In 2018, the Clean Energy Act directed BPU to require utilities to achieve annual reductions of 2% of average electricity usage and 0.75% of annual gas usage. And more recently, in 2023, Executive Order 316 directed the state to advance the electrification of 400,000 additional residential buildings and 20,000 additional commercial spaces by 2030, with an additional 10% of residential units in low-income households that would be made electrification ready. So what do we mean by buildings decarbonization? So essentially, it refers to methods that reduce greenhouse gas emissions related to buildings. The key strategies that we are talking about are improving energy efficiency and reducing fossil fuel combustion by replacing it with electrification. And one thing to note here is that energy efficiency is important because energy efficient buildings use less energy and provide most cost-effective ways to reduce energy use and emissions while making it, and therefore, they are the ideal first step to decarbonization. Electrification is basic, as I said earlier, it uses electric heat pumps for space heating and cooling, as well as for heating water. And EO 316 defines electrification as the retrofitting or construction of a building with electric space heating and cooling and electric water heating systems. So heat pumps are the best technology that is available there to replace gas furnaces. And that is because heat pumps move heat, they don't generate it. So if you see the schematic, and I hope you can, I don't know how clearly you can see it, but the schematic on the right, it shows that heat pumps are essentially made of two components. There is an indoor unit that's indicated by the yellow house on the right, and there's an outdoor component that's shown on the left, and these are connected by a refrigerant line. So in the heating mode, the heat pumps extract heat from outdoors to heat the inside of a home, especially in wintertime. And in summer, they work in reverse, extracting heat from indoors to cool the indoor building space. And they are typically about 200 to 400% more efficient. And with that, I mean that 1 unit of energy input can transfer 2 to 4 units of heat. And these are, more efficient than 95%, or I think latest gas furnaces are about 98%. So there's clearly a much higher level of efficiency that we have from these heat pump technologies. There are other type of heat pumps also that are available, such as geothermal heat pumps that transfer heat from below the surface that is at a constant temperature. But regular air source heat pumps typically don't perform as well in colder temperatures. So we have a newer technology called cold climate heat pumps that show superior performance even at temperatures at as low as 5 degrees Fahrenheit. So in New Jersey, in climate zones 4 and 5, we have to make sure that we incentivize cold climate heat pumps as part of our decarbonization strategy. Some important considerations in buildings decarbonization. So now with electricity being used to heat homes in winter instead of natural gas, the electric peak load is going to shift from summertime to winters. And there is a way to handle that using energy storage technologies such as batteries and smart technologies that can shift the demand based on, say, time of use tariffs. So this would be a part of our demand response program. And electrification, and also another thing to note is that electrification would not be effective in a home that is, that has a leaky building shell or, poor insulation. So weatherization is an important prerequisite to see that we see the full benefits of electrification. So BPU staff has proposed building a decarbonization programs in the new triennium cycle that is starting January 2025. So these would be startup programs with the main, that would gather performance data and track metrics to inform full-scale programs in the next triennium cycle. So what we want to track is, what are the energy savings, emission savings, bill impacts, and what we want the utilities to propose as BD programs as part of their energy efficiency portfolio, prioritizing residential and multifamily buildings and also small-scale commercial. We want to focus on net source energy savings. So we want the main criteria of these building programs is that they should result in net source energy savings on a fuel neutral basis. Irrespective of the fossil fuel that is being replaced, we should see net energy savings on a fuel neutral basis. And then these programs should incentivize heat pumps, cold climate heat pumps, heat pump water heaters, and electric appliances such as electric dryers, induction stoves, that are also part of our electrification strategy. And then with the reduction in energy consumption, switching away from fossil fuels, there would be, we are going to see reductions in emissions, improving indoor air quality, and we would want these programs to track that. Finally, these programs should be accessible to low-income customers, especially those that are not served through existing BPU programs, BPU and utility programs. And of course, we want these programs to take advantage of the electrification rebates and tax credits that are being offered through the Inflation Reduction Act. So currently, we have been allocated $91 million as part of the electrification rebates and $91 million for energy efficiency measures. So we would want the electrification or the building decarbonization programs in the next triennium to take advantage of that. So currently, BPU is reviewing the utility filings that include these BD programs, and collectively we are hoping that these would help achieve our state goals. So that is all what I have in my presentation today. Thank you, everyone, and happy to take on any questions.
So how much rebate somebody can expect when they put the heat pump in the house, mini split?
Yeah, we are, so actually the utility filings that are currently out there, they are providing heat pump rebate of about $3,700. So that is what we are expecting customers to take take advantage of. And then there are also tax credits that would offer up to 30% of the total project cost, and that is through the Inflation Reduction Act.
So if somebody install
programs.
himself like a DIY, then also he will get a rebate?
Actually, I think these are the programs that are being proposed are, I think you have to go through a contractor. But I think if, because we want to make sure that, they are being properly sized and, they are meeting all the state goals and met, and so I think currently, I think we would have to go through a contractor if you wanted to install a heat pump and take advantage of the incentives. But I mean, you are, of course, as I said, free to apply for the tax credits that are through the IRA.
Any more questions?
If not, I'll turn it back to you, Paresh.
Thank you, Rupa.
Thank you.
Stallings, you are next.
Okay, great. Thank you, everyone, for inviting me on today. My name is Mike Stallings. I'm run a company here in New Jersey called Capital Distribution. Pardon me 1 second. I'm just putting in my screen here in my presentation to get things started here. Bear with me 1 second. I just want to get everything squared away. So today I wanted to talk about one of the solutions that my company offers called the Smart Valve. And what I want to kind of go through a little bit about how the cost of water and sewer has changed over the years. Over the last 10 years alone, we've seen increases of close to double since 2012-13 area, at least through 2022, 2023. The new numbers aren't out yet, obviously, but it's becoming more and more of a problem in terms of from a cost standpoint. Water and sewer never used to be, but now it is becoming more and more of an issue. I'm going to put a link into the chat box. This is what our interactive presentation is, and if you guys are anything like me in terms of watching a webinar, you can get bored very quickly. And we have an interactive presentation that you can always go to, and it basically is me talking for a few minutes, but then you can kind of go and see only what you want to see. You click on installs, see pictures, testimonials, the science behind it. Today, I'm just going to give an overview of everything and how the Smart Valve works and why it's becoming a more impressive solution out there for not just residential, but also commercial properties. But when you have a chance, you can always go on to our interactive presentation. It will ask you for an email and a name. We're not looking to capture all that, but you can put a fake one in there if you want. But it gives you an opportunity to see a little bit more about the Smart Valve. So the main issues when it comes to the distribution of water, several potential problems that can occur are usually based on either pressure, what the flow rate is, and turbulence within the line. And what typically happens is anytime you have volume of water passing through your meter, that's going to vary based on static and dynamic pressure, obviously, whether it's moving or whether it's not moving. The big issue is that most meters out there don't recognize the difference. They only count volume. So if there is air present in the line or the meter overspins, the meter is going to read inaccurately, especially since meters are designed to operate within a certain flow rate, gallons per minute. If it goes outside of that range, whether that's from a change in pressure from the city or whether it's a change based on demand for that particular property, can cause the meter to overspin and read inaccurately. As I mentioned, city pressure can fluctuate. You will get different pressure surges and drops based on what's going on within the system. Also, any surges can damage equipment within the property. If you get a surge and so on and so forth, it can damage your equipment. Especially this is also the case when you have high pressure coming in. Anything over typically 65 psi, you're looking at a potential to wear down your equipment and damage it from having too much water being pushed through it at too fast of a rate. So we offer a solution called the smart valve, and it's a great way to alleviate a lot of, actually all of these concerns. And it's available in sizes 3/4 inch all the way up to 12 inch, and even customizable larger than that. And besides being versatile and can be installed both horizontally and vertically, what separates this device from anything else that's out there, it's installed after the meter on the user side, is that it's externally adjustable. And why is that important? One, once this is set up, it is very much a set it and forget it type solution, but it can always be customized to that particular building. Every building, every home, wherever the smart valve is being installed, it's going to be different. There's different conditions. There's no cookie cutter way to give you a perfect smart valve for every location. So it needs to be externally adjustable. And that way on the installation, it can be adjusted to be customized to provide the most, the highest return and, the best result. But also, things can change within a building or a home. The pressure could be lower, the pressure could be higher. There could be more demand, less demand. Also, if you're talking about, for example, an apartment complex, you might have 50% occupancy, and that could very easily in a few months become 90% occupancy. So it allows the flexibility to adjust this after it's installed so that, as things change, it can be compensated without uninstalling it or shutting the water off. So how does the smart valve work? That's the big question. What the smart valve does is essentially it acts like a toll booth. It's going to maintain the pressure between it and the meter at a constant state. Typically, you have a pressure coming in from the street. Anytime there's a demand, a few things can happen that can cause some chaos there on the line. One, you can get a large demand. If you picture an apartment complex, again, as an example, a lot of people, apartment complex, hotel, a lot of places like that, you might get a lot of people showering early in the morning. So you have a high demand. And when you get a high demand, that meter can go into a range that's outside of its design, and it's going to overspin. And when it overspins, it's going to overspin in the direction as an owner you don't want it to do. It's going to charge you more. On top of that, when you get a pressure drop at the meter, you're inviting any pockets of air that are present in the line to expand. And when they expand and they pass through the meter, it's going to be counted as volume. So what the smart valve does is it's maintaining the pressure at the meter. So no matter what the pressure is, whether it's 40, 70, 110, it's going to maintain the pressure at that rate at the meter. So now the meter spins normally. You have a nice laminar flow coming through your meter. Any pockets of air that are present in the line are going to remain compressed, so they're very tiny. And when they pass through the meter, they're not going to register as volume anymore. On top of that, because there will be a drop in pressure after the smart valve, it's going to maintain the pressure at the meter. Then afterwards, there'll be a drop off, and that's based on where you set the valve to. You're going to get reduced consumption up the line. Again, if you're showering for 5 minutes and it's at 70 psi when it reaches you, you're going to use X amount of gallons of water. If you reduce that down to 60 or 55 or whatever the number is, you're going to use less. So there'll be a reduced consumption. And on top of that, because this can actually be a secondary pressure reducing valve in the sense, because you will get a drop in pressure depending on where you set it. It could be very minimal, or it could be, on the larger sizes, you can almost shut the water off, which I'll show in a minute. Because of that, you're getting, if the pressure is high coming into your home or your property, you're actually getting it to that range where it should be, which is that 60 to 65 recommended range, to ensure that you're not doing any damage to your fixtures. Here's some of the internals on the smart valve, and on the larger sizes, what you have is a two-stage valve, meaning that the setting determines how much of a pressure differential it takes for the first stage to open. So the amount of demand, let me get to the next one here. So the amount of demand and the pressure drop downstream will trigger that, so you can achieve the balance you need. If this were to be set at 100, which I'm going to go back to the wrong slide. As you see here on the left side here, there's an actual dial on the 3-inch and above sizes. If you were to set that to 100, you would see almost a complete shutoff. And if you're setting it at 0, you should see no change. So what's important about this is we're able to customize this based on how the building or the home is set up to get the maximum result. Because obviously you don't want to disrupt anything to the property, but on the same token, you'd like to save some money on water and sewer. So by maintaining the pressure, and again, I'm just going to skip through the slides here a little bit so you can see, this is actually being able to fine tune this to each specific property, because one, you don't want to change what's going on. You want the people, whether it's a commercial property and you have tenants, or it's a hotel, or it's a hospital, you want everybody to have the same type of pressure and the ability to function. But on the second side, you also want to be able to correct the mistake that the meter or meters are making, and make sure you're paying only for what you should be, which is volume of water, and not any air or overspinning of the meter. So to sum up kind of what I said, it's a 24/7, 365 device. Once it's installed, it's very much set it and forget it. There's no maintenance needed. It can be adjusted post-installation without shutting the water off, or doing a shutdown, or removing the valve. Keeps the water line pressurized at the meter to ensure that that you're not being charged for air volume. It's going to keep the flow rate in the designed range of the meter so that it operates normally. You're going to reduce any high water pressure, so to increase the life and efficiency of the fixtures. Eliminates overconsumption for high pressure, and it will conserve water as well, as I mentioned, and also will act as a shock absorber. Couldn't get that word out there, against pressure surges and drops, because you're maintaining the pressure at the meter. The results we see, almost all of our users say between 15 and 25% on both water usage and sewer usage, because sewer is typically tied to water usage. Our commercial properties see a return on investment of less than 12 months, and an overall savings between 5 and 20 times their initial investment, because we're looking at it, and that's based on a 10-year warranty from the manufacturer. This is just an example. The other key important part of this solution is that over time, you're actually saving more, because as you can see on the left here, if you're spending $100,000 per year on water and sewer, over time, that same usage is going to cost you over 50% more. And that's at a very conservative 5% increase per year, where in fact, in many cases, we've seen that be much higher on a yearly basis. I'm going to show, this is a quick test. This was done by Texas A&M Engineering Department. This is actually going to show the smart valve and a little bit about how a building looks in terms of stopping and going, stop starting. Let me know if anybody has any problems seeing this or hearing this. This should flow normally though.
You there?
So we also have this complete engineering study available from Texas A&M as well in a PDF. I'd be happy to send that over to anybody who would like to see a little more detail on it. But yes, it's been proven out that it does work, does save, and that's our biggest concern. It's the biggest thing we hear on a daily basis is, well, you're selling snake oil, or it's too good to be true. But in reality, it's really just based on simple science and concept of maintaining the pressure at the meter. And these next slides, I'm just going to show the advancement of the smart valve, and because it has been around for over a decade now. And we at Capital here, we actually have marketed all three of them, and we have seen this progress to becoming a more viable and even better results type solution as time has gone on. And the first generation came out about 2009, I believe, off the top of my head. It was pretty much had a one spring system. You had to design it the manufacturer designed it in-house. They shipped it out, you put it in, and that was it. If you did everything right, you should save 10 to 15%. Well, that progressed to the second generation, which was a much stronger solution because now it was externally adjustable, which was very important because the manufacturer realized, hey, every building is different. We want to customize the solution for each particular property so they can maximize the savings. And of course, conditions can always change. So that came out about 5 years ago, give or take. And then now the two-stage design has come out over the last couple of years. And now we have a much wider range. We're able to do, fine tune this to a perfect level. And again, here, let me go back. Actually, here's the second generation. This was the biggest changes. It was a one-time installation, completely externally adjustable, adaptable to changes, better flow rates, visible, so people knew it was there and knew how to adjust it. And by the way, the smart valve overall is fully certified for NSF and ANSI certifications for potable water. It does have that, so I forgot to mention that. And then moving to the third generation, the new third generation actually has 3 times the capacity of any previous design, which really opened up a lot of doors in terms of more people that we could help, more people that we could actually provide this to help them save on their water and sewer costs. Because, and as I mentioned earlier, the costs have gone through the roof. It's nearly double what it was 10 years ago. And like I said, the 2023 numbers aren't even out yet. So I can't even imagine, what it looks like now. And now the calibration is much easier. It's literally done on the larger sizes with an Allen key and a pair of pliers. So all of us can, even myself, who is not very handy, can actually go out and adjust this if need be. So that they've really taken some major steps towards advancing this technology for the betterment of everybody, whether you're a homeowner or a commercial property owner or manager. It's become a very, very viable solution. Some of on a national level, I'm just trying to familiarize everybody on here. I know I'm not trying to make this a sales call. This is more, educational side, but I want you to see that this has become, on a national level, some major chains have taken advantage of this solution and started implementing it into their properties. You'll see some big names up here. There's quite a few more, obviously, but for time and space purposes, I just wanted to kind of put these in here. This is just one case study. And again, if you go to the I Decide in the chat box there, you'll be able to see quite a few more. I just wanted to highlight one here. This isn't even the best one. This is the initial savings was 14%, which is actually one of the lower savings we've seen. Overall, that this property's been up. And again, your savings will vary every month because there's different factors there, but they were much closer to averaging over 20% as things got adjusted a little bit. We had a property out in Michigan. They did a pilot with a 4-inch valve on one of their apartment complexes. As you can see from the testimonial here, their bills were averaging between $8,000 and $13,000 a month, and that went down to between $2,000 and $4,000 a month, which is incredible. It's the highest result we've seen. And again, most people are in that 15 to 25% range, which usually they're very happy with. But these guys had an astronomical result. And the other side note to this, and it's not in the testimonial because if you see the date, this was pre-COVID, but after COVID hit and we were all in lockdown early in 2022, I got a call from them and they asked me, they said, Mike, I don't understand. We're only saving 5% on our water sewer costs now. What happened? I said, well, COVID happened. Everybody's home. You have 400 units in some of these buildings, and now you have 800 people at home. I said, if all they're doing is just flushing the toilet once more per day and you're still saving 5% over the year before, it's working because we all were home for those months. And you know, you think about, you know, the differences between not just flushing the toilet, but we were all washing our hands. We were washing our Amazon packages. People were saying, hey, you have to, you know, spray Lysol on your Amazon packages and, you know, washing your hands at home and you know, we're not going out to eat. So it was such a testimonial that, hey, you're still saving money even though your entire complex is at home. I mean, I said, you guys should be doing cartwheels. You're saving 5% on a property where everybody's been home, and last year they weren't. So it just goes to show that it can make a big difference. And this was actually an engineer who recently retired, Bruce, in New York City at Met Council. They had this installed back a few years ago, and they saw 25% savings as well. And they implemented it into multiple properties. So just to kind of sum up a little bit, and I'll take a few questions after, the biggest factors and why the smart valve is so effective, is such an effective solution, is it's maintaining the pressure at the meter to ensure that it's reading accurately, not overspinning. It's going to prevent pressure spikes from demand or in change from the street pressure. It's going to ensure that you have a nice smooth laminar flow running through your meter and reaching your fixtures. And it's also going to reduce the consumption in the point of use applications like for showering or washing hands or things of that nature. Obviously, you can't save on usage if, you know, and it's very hard to save on usage because usually if you need a gallon of water, you need a gallon of water, or if you need 5, you need 5. But in point of use applications, it can also save on consumption. And with that being said, that's all my presentation. Can I answer any questions about the smart valve? Or
Mike, I have a question. What have
Sure.
the water utilities said about the device?
We actually, believe it or not, Suffolk County is one that actually offers a rebate for getting a smart valve installed. And because it's installed on the user side of the meter, you know, it's not, you know, typically anything before the meter up the line towards the street is the responsibility of the utility, whereas after, or in most cases, the meter and after it is the responsibility of the owner, the homeowner or the property owner. But yes, Suffolk County actually has a rebate program in place where because it's showing their grid using, you know, it's reducing their utilization on the grid. So it actually shows they all actually offer a rebate for putting one in out in Suffolk County.
Have any nationally recognized testing labs published results on this smart valve?
Just we have the Texas A&M engineering department ran a study. There's a study out on that. New York City actually approved it finally. It took a little time, but New York City actually approved it about a year and a half ago, I think. So that was fun. Trying to get that through. That was definitely a challenge. But yeah, there's a lot of and there's more videos besides the one I showed from the engineering department. And there's actually, I think it's a 50 or so page engineering study. I don't know if I can add it to the chat here as if somebody wants to see. Is that possible? But in any case, if anybody wants to reach out, I can definitely send it to you if you want to see more on it. Okay, any other questions? Okay, thank you very much for the time today. I hope I was able to provide some insight on this.
Thank you, Mike. Now, Dr. Pankaj Lal is on.
Okay, hi. So I'm trying to say, so I'm Pankaj Lal, I'm Director of Clean Energy and Sustainability Center. Oh, means Paresh, can you share my slides if possible? Because it's
No,
not giving me permission.
you have to
The
share the
PDF
screen.
Then it says that I'm using my university computer, so it's saying security and privacy concerns. So
Okay.
means the PDF one that I sent you, if it's okay.
One second. How to do
Okay. Otherwise,
more screen share view. Show chart. Suresh, how to do that screen? Oh, share here, share. And share the screen, right?
Yeah. Okay, we can see now.
Okay, Pankaj, you can start delivering.
Did we lost him? Pankaj, are you there? Okay.
Yeah, he may be changing some of his thing.
His video is frozen.
Yeah, his video is frozen. What we can do? We can start.
You want me to start?
Yeah, I think that's a better idea. Let me go back and change the. Where was that? Stop screen sharing. And yeah, Sureshji, you can start because.
Okay. Can you see my screen, Paresh?
Yep.
Good afternoon, everyone. This is Suresh Sharma here from Massachusetts. What we're going to talk about today is the SOFC fuel cell, how that technology can help us to reduce the carbon footprints and also help us with the resiliency. Again, our technology is basically nothing more than just backup generators. It runs with the natural gas, biogas, any hydrocarbon gas, plus it will support the green hydrogen. And our focus is basically home market, farmers, and EV charger. These are the three markets we are focusing on it. In this presentation, I'm going to answer some of these questions. If the H2E system is cost effective and efficient, if our system is reliable, and can our subsystem support power, heat, and water for 2,000 square feet home? That's the configuration we are basically working towards. Our system can scale from 0.5 kilowatt to megawatt. And our systems, the SOFC fuel cell also can produce the green hydrogen. It can also produce the ammonia, and it produces syngas. And eventually, we will also produce the medical grade oxygen in future. So, is our system is efficient and cost effective? Answer is yes. Our system, when you use our system, it can help you with the heat and power both. And it can also help you with the cooling. Our efficiency of the system is 95% today. The power is 45, it will go up in next phase to 53%, and the heat is right now 50%. If you use our system, there is no distribution loss. Today, when you get the electricity from the grid, they charge you for the distribution line items. If you use our system, you don't need a backup generator. We literally don't produce any CO2. You can, if you use our system, you can claim the carbon credit. Our system is always on. It's always going to produce power. And that's the reason I asked the question, is in New Jersey, do they allow net metering? You can modulate our system. You can run at 30%, you can run at 50%, or you can run at 100%. So it can be the load following. Our system has very long life, 15 years. There is no moving part in our system. It's a very quiet system. Our system can produce 13,000 kilowatt power per year and almost 20 kilowatt heat per year. So if you have excess power, you can sell it to the grid, just like solar. The second question we're asking is our system is reliable? Answer is yes. We have tested the system with 3 million hours in Europe. We have 10 systems running in North America now, and we are trying to test this thing for last 1 year. Our system can be warranty for 15 years. And it's always on 24/7. It's not like solar or wind. We are always on in the last mile. The third question we were asking that can we support the power requirement for 2,000 square feet home 24/7? Answer is yes. We produce almost 13,000 kilowatt power per year if you run all the time. We can integrate with the solar battery as well as the grid. You know, in a summertime, if you don't want to use our heat, you can put the absorption chiller and you can convert to the cooling also. And as I mentioned, our system is very reliable. Life is 15 years for the systems. This is how we basically trying to implement the system across the world. We are creating, a microgrid. Basically, we have solar, battery, grid, and fuel cell. So we can support the requirement for the home. And it's not like a backup generator that is only turn on and off. It's not like a backup generator. There is no mechanical component. And it's very quiet. It's a chemical process here. That's why it is very quiet. This is just one of the systems we have installed in one of the labs in Ohio. This is our fuel cell stack. We are connected to the electrical hookup. We're using natural gas here. And our system produces the hot water and heat for the hot water also. In the next slide, you can see this is how we do create a microgrid. We can have a 1.5 kilowatt systems. We have inverters in the system. We can connect with the 5 kilowatt hybrid inverters. We can connect to solar and battery, and we can put the power out to the grid or EV charger or the home or commercial load. If you look at our system size, it's not more than what you see in hot water tank in your basement. Okay. So these are the key, bullet point we are covering here. Our system is ICHP. We are very high efficient system and we are always on. And if you can get you agreed to agree with you, then you can sell the power back to them. So you can save them money with our system from day one. How we going to go to market? This is what we're going to do. We're going to do sales and marketing through the co-manufacturing. We will allow some people to build the system under their brand name. We do work with some of the generator manufacturing companies and electrical contractors. We will do direct mailing and promotion. We are also working with a company in New York and Connecticut where we can put together a program. So we can put the lease program or we can do power purchase agreement for 20, 30, or 15 years. That's our vision. We are looking for partner for manufacturing as well as we are looking for partner for distribution. Any question?
I would certainly like to talk to you. It fits right in with a lot of the solutions we offer, Suresh. So we should certainly talk offline afterwards.
Yes, absolutely, absolutely.
How much will it cost for a residential application?
So right now, today, because I bring from Europe, the cost of system is $20,000. Shipping cost goes from $2,000 to $3,000, depends on how they deliver. My goal, if I assemble the system in North America, in New Jersey, Connecticut, or anywhere in the United States, I believe that my cost can go down to less than $15,000. In the long term, my target price is going to be less than $10,000. So in future, I'm really not going to sell the system. I'm going to put the system free of charge in your house and show you the saving, and I will collect the money from the saving only. But I'm not there yet. I'm setting up the big manufacturing plant in India, China, as well as in North America. And once I bring the cost down to less than $10,000, and with the 15 years of life, right? So basically capital cost is less than $700. So and you can easily do net metering. You can easily save the money, from the power, selling the power or with the heat. So this is the only such technology that can produce power and heat and water at the last mile. And with natural gas, biogas, propane, LPG, CNG, and green hydrogen. And this system runs on reverse mode. So the water which we produce, eventually we will produce from that same water, the green hydrogen. So we will have in future the closed loop system, but I'm not there yet. The technology is very proven. We have a lot of experience with this technology and it's very scalable. We are building megawatts electrolyzer right now overseas for the other projects. And our goal is to build the electrolyzers and build the power system. If you look at the Bloom Energy, they have done a wonderful job in California and also other part of the United States. They have built a bigger system. They're building megawatt systems. And now they don't sell the system, they sell the power only and the heat. So with this technology, we can guarantee you, I did a lot of study for the solar battery, backup generators. Backup generator market in the United States for the home is around a few $1 billion. And that only use 6 to 8 hours or 10 hours or 50 hours a year. Our system from day one can give you power and heat and the clean water. You cannot drink this water. It is not drinkable water. It does not have any minerals, but it is pure water. Any question? We have
sure.
systems running in Ohio, Michigan, Portland, Oregon, Arizona. I think 2 systems in Ohio. So we have roughly 10 systems in North America right now.
Suresh, is there a contact number for you so I can reach out to you later on? Email?
Yeah. Sorry. Here.
Okay. Okay, great.
Any question, Paresh? Anybody? Thank you so very much again. Pankaj, your call. Yeah. We can see.
Yeah. So I'm glad I had to change the computer, but I'm glad that we covered that up. So I'm Pankaj Lal. I'm a professor at Montclair State University. And I also started the Clean Energy and Sustainability Analytics Center. So when Paresh reached out to me, he gave me talk about the university's sustainability and energy initiative. So my presentation is divided into 2 parts. Means I have my colleague Amy Ferdinand, who is the director of facilities, and also Raleigh Ferdinand, who is managing the cogen plant, as well as he is my student as well right now. So I'll be talking about the facility, the university. When we talk about the initiative, one side is the facility side, and the second part I'll talk about research or engagement side. So a quick overview, we were one of the pioneers. The university started Montclair State, we signed the MOU with EPA back in 2009, focusing on the green tech and practices on our 246 acres campus. If you are not aware of where we are 14 miles from New York City. It's in northern Jersey. And if you have not been to our place, I invite you, I take this opportunity to invite you over at our place. So the facility sustainability, we have been working for quite some time, but in 2018-19, we started renewed focus on sustainability and the development of a sustainability plan, something thinking about short-term, medium-term, and long-term plans. So thinking what we can do on the facility side. So this is based on the sustainability plan that we developed together. And in a way, the university renewed its focus, but it identified 6 focus areas in a way, like the buildings, then unified approach to campus, how can the facilities engage in outreach and education. We are at the core. We are an educational institution where students are at the core of what we do. And then low carbon campus mobility, so maintain high quality, efficient landscapes. So some of the languages and others was I'll not go into the full detail, but Mike was talking about microgrid. So we say that we produce our own energy. We have a CHP plant, 75% of our annual electricity comes from cogeneration plant that we have. And then we also have microgrid, 5.4 megawatt microgrid. And Paresh asked me oh, can you throw in some numbers in terms of what we are using and others? So slightly COVID provided some disruption. So we are using sometimes baseline when we use pre-COVID years, because 2020, 21, when most of the university was virtual or others, the footprint or other, the data is not, our baseline would have been different from the regular year. So sometimes we go 2019, then 2022 will be much closer to our baseline, what we think. So again, a microgrid, 5.4 megawatt microgrid, which is a natural gas turbine one, and 4,300 average homes. And we started in 2016, the microgrid. So 2013 was our cogen plant and others, and the rest 25% comes from PSCNG, but 75% is quite a lot for the campus that we are able to provide ourselves. Then some of the things that we talked about, in terms of the short term, in a way, what we are. So this started in 2022. So we are in a way already in short term. 2024 is the short term, and then medium term, long term is 25, 20. Medium term is 2025, 27, and long term is beyond 2027. So that is the way we thought about like where the university should focus. So we retrofitted. I mean, some of the targets or goals are like short term we have achieved, but I'll go like where the university is moving in terms of where we are thinking in terms of like retrofitting buildings, because we have a mix of new buildings, old buildings, and the way we joke around is pretty old buildings. So thinking about like we face as a regular setup, like thinking about a commercial, like we are much closer to the commercial sites of universities, but our needs and others are also higher because lab and others are where rather than a typical commercial establishment, they are energy hungry in a way. So we focus on that. But we also looking at centralized building management, opportunity to pilot emerging utility consumption, accountability standards, and others. And then water consumption and annual potable water cost. So we were like in the 2019 around 1.3 million, but we are trying to reduce that quite a bit. And we have our like short term 5% or 10% when we talk about. We are on the other side, we are also a growing university. Like in 15, 16, we were around 16,000 students. Right now we are 23,000 students. So it's not just the need is not just at the built up area, but also on the other side, the demand side is increasing. So that's why when you look at the short term or medium term, the demand is increasing on the side. That think about a consumer base is increasing, facilities are increasing, but not at the same pace. But water and others, these are some of the things which are sensitive to how many people are there, how many students are there, and others. But we are focusing on the potable water cost, like how to reduce and how to optimize. And we are thinking about like we have been working like facilities work very closely with the education sides or research side. So it's an integrated approach. Think about like if the changes are there, then you have a validator and researcher in-house. So that way we are university has some of the benefits. So we are focusing on water sense level, like cooling tower concentrations and other that we are trying to optimize operation. Then the one of the major focus has been energy use intensity and annual energy cost, like how can we make a dent on that. So we are like baseline is 286 is quite high, like square foot per year. Think about like a lot of our research is energy heavy. For example, we'll have the even some of the energy research that we do or the labs when we run our experiments and others, like they require quite a bit of energy. So that's why it's much higher. In 2019 it was 18 million, but we are trying to reduce the energy usage with new built up areas and new students. Means we are still onwards looking at the goal of making a dent on being more efficient, and also like our EUI. So decrude. So college university buildings typically is 84.3 like CBA, but another part is like we are in the northern US, so heating cooling needs are there. Means New Jersey has heating needs, and also the other part is like urban area condensed campus. So that's why it is much higher than the average, but we are trying to make a dent on that in terms of high demand systems and others that if we can do. But lab and others, whichever, like I work in College of Science and Math, so we are one of the more energy inefficient way, like our labs are quite a bit energy hungry. Then another part that we wanted to talk about is like how we are focusing on energy, like greenhouse gas emissions. One of the things we targeted is like borrowing from the ESG side, scope 1, scope 2. So we have been like looking at again, why not 2021? Because that is a disruptor, like COVID disrupted our business operations. So that's why we are more backward looking in our like, and then 2023, 24 it will be. So we have been on a whole like GHG emissions when we map out, like we have been on the whole pretty stable. I mean, there has been some increases in 2018, but that was when 2 of the new buildings opened and we expanded quite a bit. So that is one of the reasons when GHG emissions, and also you have to look at the consumption side. But what we are like in scope 1, which is again for borrowing from the ESG side, that scope 1 addresses direct emissions are controlled by Montclair State University's on-site combustion and others. So here we are emphasizing the least carbon intensive energy sources, cogeneration plant, utility grid, and investigate opportunities. So one of the ways where we are working quite a bit, like Amy is here, who is the director, and Raleigh. So we are looking at energy efficiency as one of the major sources in terms of like how we can reduce our direct scope 1 GHG emission. Another part is the scope 2 GHG emissions, which is mostly the purchase of electricity, steam, heat, or cooling. So here we are again looking at the energy efficiency upgrades, retrofitting, and others. So we are short term, like is 2024. So we are on the target in a way, like 5% reduction with increase in enrollment, increase in student, and increase in usage. But we are also looking at power purchase agreements, and recently we also got the REC certificate, like carbon offset purchases, that it can come from the cleaner source of energy. So that is one of the successes that we have focused on 2023. That is a 1-year agreement, but we are planning to renew that. So implementation of demand minimization strategy. Another part that we focused on quite a bit is like the green building infrastructure. Our newer buildings are moving. If you look at this one where we started with the silver one, but now we are moving toward the gold one, like the new buildings that we are focusing on environmental sciences, School of Business, and others when they started. So these are the new buildings which are much better, much more efficient. That is the way I'll say. So LEED certification is one of the areas where the future we are saying that the path is always better the way we are operating in the facility side. On the side, another part that we are focusing on is the waste diversion, like short term to long term. The idea that we have been tracking one of the construction waste, because we had like 3 large buildings, more than 100,000 square foot buildings built in last 5 years. So new construction is another one that we have been focusing quite a bit, that can we divert those new minimum construction waste, it can be more, means we can be more efficient on that side. The other part is what we see in a university, typical waste generation, when you have dorms and also resident population living in. So we are thinking like how we can make a dent in terms of our target is there, that can we recycle more, can it be more efficient and not going to landfill. So this is on the generation side, not just on the user side. So that is also, yeah, education and behavioral change also plays a role. But other part that we are looking at purchasing policy, and also can we be more efficient in terms of our procurement and other things, like also hand dryers, automated fixtures. These all come at a cost, but thinking about a mix of large establishment where you have a mix of old, new and very new buildings. So we are moving towards the way where we can even make some of the existing facilities, older facilities, more energy, water, and more sustainable. That is the way we are thinking. The other way that I'll focus on is like our baseline was 85%. How can we increase our, like, so waste stream is diverted from landfill in tons. Our target is like in next couple of years, if can reach 90%. Right now, we started off with 75 to 80. So it has been moving on that direction, but it's not like these percentages. When you look at again, the last mile is always the most difficult one. So we are looking at that side. We are working with the vendors. We are looking at point of usage, signage, and others. And some of the way on the facility side, just in like last 1 year, thinking about half of like the short term one, we have like REX is one of the things that we focused on renewing annually. Then new hire trainees. So one of the ways anybody like who comes in now, we have in a way sustainability trainings, then facilities, and then the energy efficiency side, upgraded machines, baselines for transportation. We are not very efficient in the sustainable transportation side. We are limited in terms of electric vehicles. We also thought about hydrogen based buses and others. So those are some of the areas we can do better. Electric transit vehicles, charging also, there is quite a bit of scope in there. So those are some of the areas that we are focusing on. And HVAC is another, like anybody who works with large commercial buildings will talk about that. These are some of the things that we are trying, but this is mostly look at the report card as a 1-year report card when we started, and the path is greener. That's the way I'll say in terms of our facilities, like where we are. The second part of my presentation will talk about mostly on the research side. The first part was facilities, where I owe a lot to Amy, who is the director of facilities, and she's here. So she can also jump in at the question time if you have something about that, or I request Amy and Raleigh to also jump in. The other side is university is at the core is the research, education, and others. So that is where the CSAC came in 2018. We are pretty new in a way, like later part of 2018, 5 years. The focus has been research, but interdisciplinary research. We see like it's engineering, like so computer science, in other engineering, civil, electrical, all engineering work toward the energy goal. So it's not a just a domain of just the energy practitioners, but mostly dominated by energy practitioners. But we thought analytics data can speak for itself, be it sensor data, be it computational data, or energy data. So there we said that is the part we saw sustainability always as a concept which brings analytics together. So we thought energy and sustainability focused on the data and models. So that is the way we see. And research policymakers, we work with diverse like transdisciplinary approach. We have been doing that like a regular summit. So it will be in May, 5th annual summit where we bring everybody along. But we have been doing okay on that part, like the CSAC. But what are we doing? Our primary mission still remains research, education, and outreach. So how can facilitate campus as a lab itself? So that is the way we see energy and sustainability. Campus is not just a facility or a commercial establishment, but it can be used for research itself. So that is where we make a dent, and we work quite a bit with the facilities and the research groups together. So that is the way I'll say CSAC has provided a model on that part in last 5 years. So we are, the other part is research and education. Some of the things we do is like, I'll not go into the detail because I know some of you have seen that we have worked with BPU for a number of years, like 2018. So we have projects, and even Rupa talked about like the energy efficiency one. So we are working right now providing consulting services to BPU on that energy efficiency triennium one, which is the most recent one. So we are making a small bit. We are taking some steps toward like contributing to the shared goal of clean energy future. But the way I'll say is like women in energy, like inclusive way, like we think energy is an area where inequity is persistent, not just gender, but also BIPOC community and others. And we have made like focused approach toward that. And the other part is like we can do a lot, but where we have made impact is like some of the things like hydrogen, fuel cell hydrogen task force report, even NJDEP and others when we work with. So policy side, we say that we have made some contributions towards like on the research side, on the analytics sides. And also it has been on the federal side also, we have DOE and NSF and others. So research institution, we have made some progress on that front. And we are also like even CSAC 5 years old, like fourth national climate assessment, which is a federal mandate. So we have made some steps there. Now it's the fifth national climate assessment. So we have been making at the federal level also, we are visible. We are, means they seek us out in terms of the research part. So that is what we'll say, like we are in the national reports and others, we have done that. The other part is a traditional way of doing. We publish, like we always believe in, if it is not peer reviewed, then questions can be there. So we publish quite a bit, and like on a way, like every year, peer reviewed journal publications take quite a bit of time. So 34, almost a dozen publications each year is like we are maintaining the pace in terms of peer review, and it takes time, so there is a lag. So but we have been pretty consistent, and seminal journals in the energy field we have been working, and we have been publishing in that area. Some of the areas that we have worked in is like I'll not go into, so I'm running through because I know I have limited amount of time, but we have like where the state goals are and where our goals are, like in terms of research, our contribution has been, means in almost all the area where we think like the 6 target area, be it the energy master plan, we have done. But also the international part, we are like not inward looking, but also outward looking. So national level, international level, also policy making, Kenya, Rwanda, bit Africa, or also Vietnam or Nepal, India. Means we have international, but mostly focused on New Jersey. So I'll say like most of our research, around 70% is New Jersey or regional focus, and 30% is national or international focus. Then modeling and analytics is again our core stay, because we share, like we see our center in between 3 buildings. Our offices are in chemistry building, which is the science hall, we say the computational science or computer science, school of computing, and environmental. So our center brings the 3 main core areas together in terms of engineering. Also, that is the way we see analytics brings all of us together. So we have been working on number of projects, and load forecasting, grid analytics, energy efficiency, fluid dynamics, energy security, AI. So these are some of the areas that we have worked on. We have also proprietary models and others that we have been able to develop that we use for New Jersey-wide economic energy and ecosystem analysis, so integrated analysis. And we also work with National Lab and others like Argonne, NREL and others. So we have done in now 6 years, but also focusing on community outreach projects, like working with municipalities, working with townships and other, working with even K to 12. So we see a university as an engine of growth, like Montclair State can be an engine of growth in the neighboring areas, and also North Jersey means it can be there, but where we are located, it is one of the most suppressed areas of New Jersey. Like we have Patterson, Kearney, and then Ironbound and other areas. So we are focusing our effort on community outreach projects as well. The other part that what we have been quite successful is startups. Like our startups have moved from like EDA projects starting from the initial 25,000 supports to venture capital funding. So we have some of the projects that we have been working with the startup companies and others who have moved beyond, like all of our partners have moved beyond the initial support from EDA and gone into a much longer. So one has gone into the venture capital stage, another has gone into a larger funding than like 250,000 to $1 million funds. So within last 3 years, those are some of the areas. And then another part we'll say, like we think clean energy work brings all of us together, including biology and coastal protection, workforce development. So we follow in a way integrated approach with hydrogen fuel cell storage. Means we had an earlier presenter who talked about that. So I'd like to also say that on May 21st, we are having a hydrogen workshop along with EDA and others, and I'll reach out to Kevin and the group as well. So May 21st will be our hydrogen energy workshop. So we wrote the fuel cell and hydrogen report, means for the New Jersey Fuel Cell Task Force, that was like released last year. So that was one of the work that we did. Then recently, what we are very proud of is like EDA Office of Research and Development reached out to us. Like we are working together because they tried to do a model for New York City, but they said it has not been field tested. So thinking about like a city based or municipality based tools, which can basically give you energy as well as economic impact. So it's an integrated one. So that is what we have been working for 1.5 years with EPA, Director of Office of Research and Development. And hopefully this will lead into like decision making at the local level. Like the model that we are doing, it's pretty diverse. It includes like quite a lot of sectors, like, and we can talk about like if in detail, because it takes the real data like geospatial data, the real energy data, different domain data, then builds it puts in the economic layers. It also puts dual optimization, energy and economic optimization together. So least cost pathway for new policies, even at the smaller scale. And we wanted to test it at some of the vulnerable communities. So we are thinking about Patterson, Brunswick, Camden and others. We need 4 pilots and others. That those are the most stressful ones for these kind of models. These kind of models work well for a larger communities, but if it works for a smaller community and also the LMI community, then that is the way we say that is the gold standard of research, that your results is much amenable to like the real world. So that is what we have been working for 2 years now, like last 2 years. So thinking about the R&D effort in that, like city-based planning tool or a municipality-based planning tool, which can give a decision for different sectors, policymakers, but not just energy, but energy, economic, and you can optimize different pathways for that. So that is the way we have been working with EPA. Another work we have been doing is like on the offshore wind side, RMI, where we are looking at the fishermen side. So that is one of the most challenging work that lot of voices or others, community voices came against it. So we are tracking, even NOAA tracks, but NOAA does not track into a different kind of period. They focus on snapshot surveys, that once surveys and the time change, then the results might vary. So we are looking at a series of surveys and also a dynamic model, which can give you a pre-construction, then during construction and post-construction. So we are under that, doing that as well. Then industrial ecology, one of the path we say supply chain, like value chain and supply chain are used interchangeably, but there is a difference. And even rather than the Excel based like BOEM tools and others, can it be more means research oriented? And we are looking at sensors, we are looking at real-time data collection, robotics, sensor, as well as the data that we get from the electrical engineers and others. So these are some of the areas that we have been working in. Then we are also, water is also like Dr. Deng, he has a lab, like our collaborator has a WISE lab. So we think water innovation, sustainability and energy areas, engineering areas is another one like a lot of water engineers and others work in. And then we are trying to integrate that into climate change impact and others. So I'm not going into detail. I'm giving you a flavor of what we do, but not going into detail into much, means understanding that I have a time constant on my hands, but look forward to your partnership and collaboration. We are first thankful for support and from BPU, like we had competitive as well as other contract with BPU, DEP and others. Like we have, that is one of the areas that we identified, like we have to make a dent. But another part that I'll say, means I generally say, give these presentations, but it takes a village. We have a large team working behind, and Chivukula talked about Rupa. He joined us. He's a senior advisor of us, but it's a large team. What you see is not me. Means it's a group who is always working behind on the CSAC side, and we have a lot of collaborators, like a lot of collaborators who are not our full-time or not our employees, but we lean on where we are not able to do, like we lean on national labs. We know that university research is limited, it's slower, but where there is a faster turnaround, we lean quite a bit on the private sector, energy labs, as well as other collaborators across US. So that is what I had to present, and I'm open to questions.
I have a quick question. We're also a local-based business here in Bloomfield, very close to Montclair State. So I had a question. You probably heard my presentation earlier about our solution, and from the private sector, we've heard that because even though the main savings is correcting the mistake at the meter, it would still fall in terms of from private companies saying that, you know, this meets our guidelines for reducing our usage on water and sewer. And I just wanted to pick your brain a little bit about, do you see that also our solution being recognized as a because it is reducing the actual bill by 20% or more on water and sewer? Do you see that as a clean energy initiative? Because you know, the proof is in the pudding. It's reducing it, even though it's more correcting a mistake as opposed to actual consumption.
Yeah, means it depends on how you say. So yes, the answer is yes, we see that. Means it might be we'll put it energy and sustainability solutions. So that's why we say not just limited to the energy solutions, but we see it. But again, proof is in the pudding. We need validation. And we talked about Texas A&M. It's a well-established lab and a research one. So that is the way. And I'll lean on the university side. Yes, it is, but on the research side. So it has both the facility side. So I'll defer to Amy, who is also here on the director of facilities, that how it can be utilized. So that is the more action research. We also use campus as our lab. So that can be one way. The other side is if you need improvements or research space or collaborators for which students want. One of the things that we always say, like being a doctoral institutions or others, we have one of the trainees, like we treat our doctoral students as interns in a way, like thinking about if you can make a real world change. So that can be another way. They are low cost, but also working together, they learn and you benefit. That is the way we think that university and private partnership can take two forms, as a testing one, which is more on the facilities side, and on the other side, research side, where we come in.
Okay, thank you. I appreciate it.
And Bloomfield is very close. So
yeah, we should have lunch one day. We're close enough.
Even if you are not, I live in Princeton, so I can come to Trenton or other areas.
Okay.
Don't forget, we've taken over the campus in Bloomfield just recently, so that might be a nice little pilot test space.
Yeah,
also.
We also have now two campuses.
Yeah. Wait, you took over Bloomfield College, right?
Yeah. So
okay,
now
that's
we
right.
have two campuses. Yeah.
Okay.
And that is another, I forgot to mention that our sustainability plan that I presented on initiative is in the main campus, because when we drafted it, Bloomfield was last year. So now we have to revisit that one.
Great.
Yeah.
And Kash, that's a really impressive body of work. I was wondering if you collaborate with other universities in New Jersey on these sustainability initiatives.
Yes, we do always. Like we have collaborators with like Stevens, Princeton, Rutgers. Means we collaborate with everyone. Rowan means larger, and even community colleges, not just like universities. And even schools. Like we see school districts also as a major pilot and partner. So that is the way we see. We behave. Means we are one of the universities, but we work with other as well as like the school. We say that school districts are also one good collaborators, not just the community college or the four-year universities are larger.
Thank you.
Pankaj, this is Suresh Sharma here. Do you guys have any fuel cell programs in chemistry department, chemical engineering, where we can bring some R&D projects?
We don't have a focused fuel cell program, but I'll invite you to that. I noted that down, like May 21st. We will be having a hydrogen energy workshop, which is a fuel cell and others. 2 years back, it was at Rutgers. We could not do last year on the hydrogen day, but we are doing May, and it is free. So for our collaborators and others, and might be BPU folks, I have a plan to reach out to you. EDA has committed some, so giving you a heads up. Like we look forward to.
Yeah, I'm doing a lot of work with the what do you call smaller digesters in Seattle, Washington. We're producing the biogas. For some of the schools, they have cafeteria waste food, and from there we can convert into biogas. Okay, and then we also building the small rest area. We building the EV charger also. So I like to bring some of my R&D work from Germany to here, if I can. That's my goal.
Means I'd love to talk to you more. So means I put this in, but otherwise, like Amy is also here, Raleigh is also here, and means and even Chivukula is here. So we all think together. So we'll love to talk more about it. But one thing I invite you to May 21st, and before that also we should get together, not wait.
Okay. Thank you.
For that.
I have a question, Pankaj. This is Virind Singh.
Yeah.
We are developing robots. In fact, I will be the next speaker. We are developing robots to charge electric vehicles. And do you have, our prototype is ready. We need a robotic arm. We have all the things lined up with the vendors and all. Do you have capabilities for programming robotic arms or associated functions by any chance?
Yes, we do. The cross lab that I talked about, like Waiti and Wang's lab, is that the robotics group. We also have like a larger robot like NSF and others. We have a $450,000 robot and others. So we have those capabilities, but we have a dedicated lab with students, also trained students. For example, one of the things we are doing is smart lawnmowers at a lower cost. So that is one of the. So we have that capability, and he is also one of the associate directors of our center. Like he's joining from the fall, but he's already working with us. So he is very integrated in what we do. So let's talk about that, and might be me, you, and Waitian can get together and think about how we can.
I'll follow up with you. Thank you very much.
So Paresh, means any more questions, thoughts? Otherwise, I'm sorry for like the earlier one, I had to change laptop. So my university laptop does not allow me to do because of security features on my. So I'm sorry for that. Means I apologize for that one. We are in the Zoom world. That is the way we say. Our university laptops are set for Zoom at the means who deal with financial levels and others. So that's why I'm sorry. Once again, my sincere apology for that delay.
We lost Paresh.
Virind, you can share your screen now. I was speaking with a mute. I thought that someone else was going first. No problem. Okay, perfectly fine. Apologize.
Who's next? I don't have. What was the?
Suresh Sharma.
He did it already.
No, I'm all set.
Okay. All right. My apologies. So please bear with me. I will share the screen and ready to rock and roll. Just please give me a second. Please let me know when you are able to see my screen.
Yep, we see your screen.
Perfect. Okay. Just a minute. Just need to take care of a few things so that I am organized. All right. So thank you very much for this opportunity, Paresh and the team. My name is Virind Singh. We are developing robots to charge electric vehicles autonomously, but please note it is for the fleets. We are doing it for fleets. What is it? Before we get into the products, what are we trying to achieve? Our goal is to make EV fleets operations more efficient. And how are we going to do that? Our robots will charge electric vehicles, maybe cars, delivery vans, trucks, or delivery drones. They will check the tire pressure of any vehicle on a customer site. So that is very unique. Nobody has ever done that or is doing it. We will be doing that. And not only that, our robot will be going around the vehicles and doing pre and post trip inspection, because we will have all these sensors to do that, and then give a report of what are the damages to the vehicle. So this is what we intend to do, but we will go step by step. We are going step by step. Our first focus is on charging electric vehicles. They can be battery powered or they can be induction charged, and either of them. And also we will be charging delivery drones. That is our first focus. And I will talk more about it. But before we go, why electric vehicles? By 2030, there will be 26.4 million electric vehicles on the road. And this does not mean any drones, FYI. Huge market is coming. See the ramp up. The problem is, although the demand will be there, but the charging infrastructure is not catching up. You know, it takes, if a fleet, I'm talking about fleet of trucks and cars, if they want to deploy the charging station on their site, the electrical grids may not have the capacities, or they themselves at their fleet site may not have that kind of space to put in so many electrical chargers for their 10 to 20 to 40 vehicles which are on site. Now, because they cannot do that, they cannot charge on their site, they have to go to a charging station, and it takes longer today compared to diesel vehicles to charge their trucks or cars, and they have to sometimes wait because there are, you know, a lot of vehicles in front of you sometimes. Now, this is fine and dandy for consumers, but when we are talking about fleets, they pay $100,000 to $170,000 to the drivers. And when they have to wait for such long periods of time, 1 hour twiddling thumbs, and with the downtime of the vehicles, that makes the electric vehicle fleet operation very expensive. And that is what we are trying to solve. But how, before we get on, the market is so huge. So we are focusing first, not on the cars, not on the heavy duty trucks and buses, but light duty and medium duty trucks, delivery vans. And the reason being, California has passed a law that 10% of delivery vehicles at least have to be electric vehicles starting January 1st, 2024. So guess what? UPS, FedEx, DHL, USPS, all have to comply with that. And that is a great market for us. Now, the problem is all these vehicles, whichever are there in the marketplace, they are from various OEMs. And each of these OEMs have different standards. So it becomes difficult for any vehicle fleet, vehicle unit to optimize their operations. And this is the best part of the thing. What are we doing? This is our solution that I would like to share with you. And of course, if I can bring that solution to, apologies, the videos, it's challenges sometimes, but we will get there. All right, I'll pull it up from here. So basically, a driver comes and drops the vehicle, brings the vehicle, and says, charge my vehicle. The robot gets the notification, picks up the battery, and takes that to the vehicle, connects it, leaves the battery there, and let the battery charge the vehicle, and goes and repeats that with other battery and other vehicles. So that is what our solution is all about. Now, I already talked about that it's a huge market. Right now, by 2030, the global market for charging will be 113 billion, and for US it will be 19 billion. In our category itself, it will be about $5 billion worth of charging. So there is a huge thing. That is, we are very well positioned in the marketplace. Yes, we have done comparative analysis. There are certain competitors who are doing a few things, but they are all in the cars. They're only doing for the cars, and they are doing it inside. The operations are for parking garages only. We are doing outdoors, as well as what you don't see is we will be doing tire pressure management and a lot of other services. So we have a very unique place. Now, we can talk about anything and everything, but is there a total demand? We have Great Dane is the manufacturer of medium duty trucks to deliver goods as well as foods and reefers to have the foods in their trucks. They are an OEM. They have given us letter of support. Motive Power System is doing the same thing, helping us, and wants a demonstration. Goodyear, once they have trailers at the yards for tire pressure management, they're engaging us for all their service centers in the United States to test that out. And if it is okay, then they would like to invest in us and also promote our product to their customers. Hertz, they have so many cars, electric cars at airports, but they don't have the charging infrastructure because airports cannot change and bring the grids, bring the charging into those sites so soon or may never. So we have a lot of customers who are waiting for demonstrations from us. And we have others. We have started the discussions with DHL, FedEx, USPS, and Penske, other companies to develop, to have some demonstrations as soon as our product is ready. And I'll talk about the demonstrations shortly. Now, just because, you know, we are doing all these things, it's not done by one individual. We have a team of professionals. I'll start a little bit about myself. I'm a mechanical engineer with a couple of MBAs. I have a patent in my name. I went to MIT to do artificial intelligence course also. I have design engineers, software engineers, test engineers, and mentors, great mentors to help me develop this company and take it to the next level. Just to give you cannot take the company up if you don't provide a good value proposition to customers. And what we are doing is, for our customers, fleet customers, they will have minimum infrastructure cost because they don't need to install huge systems to charge their vehicles. We will just bring our robot and a battery system and need to charge on one or two of their charging 240 volt plugs, and we can get started. Not only that, no charging infrastructure costs. The cost savings due to labor, the drivers who can be used for something else is huge. When they have to not wait 1 hour and they are paid $100,000 to $170,000 a year, that is a huge saving for a fleet which has 10 to 20, at least 10 to 20 units on a site. Now, also, when we will be charging, we are doing off-hour charging. That results that the capacity utilization of the vehicle improves because it's being charged during the downtime. So the customers are really benefiting out of it on the high side. But let's get on to really what are they getting? How are they getting? So we have a revenue model of charging as a service, and the customers will pay monthly subscription fee, say $10 a vehicle for per truck or per car. And what that does is, the reason we say that is because we want the data of that car into our system. And then we will charge, say, $10 to $20 or $25 per charge every time a robot charges one of the vehicles. We have done some calculations for EV customers that have about 10 EVs. They will save about $2,000 a month per vehicle. And that, on our side, we will break even by 2026 if everything goes well as per plan. So it's a win-win situation. Now, let's talk about the progress we have made. We were formed in 2023, and in just less than a year, we have, from business front, we have raised angel funding, we have applied for grants, and just last month, to our surprise, we were recognized by Clean Tech Venture as one of the companies that to look for in 2024, and we were honored, and I didn't even know that that was coming. Now, this is on the business front, but what on the technology side? On the technology side, we have filed for patent. No other company can do the robot charging, tire pressure management, tire depth, tread depth measuring, and yard management, but we have filed a patent for that. Now, so our robot is ready. I wanted to share a little bit of it. Again, need to share our prototype because our system is not working. This is a little bit older prototype. It doesn't have the robotic arm. We are working on the programming of the robotic arm, and this is the place where the battery will be put in. And this a little bit older. More progress has been made. So prototype is almost ready, and we are excited about that. I'm sorry, it just blew up. Now, we have aggressive timelines, and we intend to bring demonstrate to our customers like Hertz, Goodyear, Great Dane, end of this year, by end of the year, demonstrate, and we are applying for VC funding and other funding. And once everything falls in place, we will be deploying. We have a great growth plan for next year. We're excited about our future, and thank you very much, and I appreciate it, and would entertain any questions you have.
So what is the size of the robot you have? Oh, how many kilowatt each?
Okay, so our initial size is 60 kilowatt to 90 kilowatt. That's what will be, which is good for cars. Of course, it's fantastic, but for light and medium duty trucks, it's perfect. What we are looking for is, as the technology of battery improves, the cost will go down, the weight will go down, efficiency will improve, and we will pass those benefits, and we will have higher level, which then we can cater to heavy duty vehicles also.
Okay. And you're going to charge them all the robot. You will charge night before, right? And then you put it to action, right? How that will work?
So what happens?
Or they keep charging every when you park them, they're charging, right?
Right. So when you park them, and there are two ways the robot can get the notification. It will be on demand from the customer. The first one will be, hey, the driver itself says, I'm done for the shift. We already know how much battery charging it requires. It says, charge it. That is one way. The second will be, they have a dispatch center. The fleets have dispatch center, and they know what the thing is. They can schedule that dispatch and charge in the night, this one for second one, third one, and they can keep on charging during the day also. It's not just whenever the vehicle is standing.
Have you looked at the forklift also?
Not yet. I know, the uses are so huge. So huge. But what happens with forklift, because it's small and it's for inside the area, there are other things that they can do. The forklift in future itself will become autonomous, that will go and park at the docking station. That is my thoughts. So we want to be outside where it is different environment.
Tesla tested a prototype robot charger circa 2015, but didn't commercialize it. What barriers did they face that you're addressing?
So their system was not a portable one. That was for people at home. And all that did was that if you come, park your car, that system will come out and plug it into your system. That was for individuals. And again, you have to go and sit in a particular spot. What we are doing is, instead of you bringing the car or vehicle to the charging station, here the charging station comes to the vehicles. And that model is best, and it is for outside. So that is what we are different from that, what Tesla brought to the table. And Tesla's model is no different than you go to a charging station to charge it. Now you're doing it at home. Now, again, as much as we would love to own a Tesla, but, if we have a plug point, we can easily do that. We don't need a fancy charger for it. So that's the reason I think I'm not that an expert on what Tesla's technology can, but it is vice versa. It is, you still have to bring the vehicle to the charging station rather than the vice versa.
Does any particular connector standard work better than others?
We are agnostic to that. It will depend on what the vehicle wants, because and hey, actually everything is becoming very standardized. It is going to CCS standards, and if not, either they will be all be Tesla standards or it will be all CCS and Tesla. So there are two standards, and that's why we are already getting the vehicle information in our system ahead of time, and based on that we will give the power with that charger. So absolutely, but we are agnostic to that.
Thank you.
Are you worried how the power will come to your battery, the grid?
So we will be using 240 volt. That will be a 3-phase input that is always required. And those can, being with the in a fleet environment where maintenance typically are done, those things will not be that will be easy for us to get at the site, but they don't have to install any infrastructure. We will just use that. We have a docking mechanism that will be connected to that, and the robot will automatically go to the docking station.
I like to talk to you after this, sometime offline, because we are doing similar kind of thing. We are charging the EV charger and also the bus, airport in India. So we can talk about that also. So we're building a power plant for the local gas station. Basically, that's what we're doing.
Okay, absolutely. We can, if we can. This is my, my contact information is here. I can put it up again, so that if you can just anybody who needs to connect with me, I have this. If you can please share. I have a LinkedIn contact also. Happy to chat.
Thank you.
Any other questions, please?
So I think we are end of this nice Engineers Week presentation celebrations. And thank you everybody, all my bosses and presenters and participants. Thank you very much. And we'll call it after.
Thank you.
Thank you for coordinating. Appreciate your
Thank you,
invitation
everyone.
also. Thank you.
Thank you, Parish. Great show. Bye-bye.
Thank you, Paresh.
You're welcome.